Okay, so we were just talking about properties of exponents, multiplication property, keep the base the same, add the exponents, power property, you multiply the exponents, and division property, you are subtracting exponents, keeping the base exactly the same. So let's practice that here on exercise 2. Simplify these expressions. So let's look at the first one, x squared times x to the 5th. They have the same base of x, so we keep that the same. They're being multiplied, so we add those two exponents, so it is x to the 7th. Easy, right? Okay. For number 2, this is a power raised to a power, so we are going to give everything inside the parentheses that power of 3. So 2 to the 3rd, x to the, this is a power raised to a power, so you multiply them, to the 6th, y to the 3rd. And then I could go ahead and simplify this, because 2 to the 3rd, 2 times 2 is 4, times 2 again is 8, x to the 6th, y cubed. Okay. Number 3, we got division. So when we divide with like bases, keep it the same. And then subtract these two exponents. 9 minus 6 is 3. Okay. And then finally, a cubed times b to the 7th. That should be equal to a to the 3 plus 7 is equal to 10. Right? Wrong. These bases are not the same, so you can't do anything with them. The answer is already simplified there, right? The a base and the b base, they're different, so you cannot apply that multiplication property on that one. Haha, try to trick you. Did you fall for the trick? How about exercise 3 here? Simplify 3x plus 2 quantity squared. Okay, so we know that this means 3x plus 2 times 3x plus 2, right? Because it means 2 copies of this thing. So this means that we want to do this whole FOIL business. 3x times 3x is equal to 9x squared. That's the first. Outside terms, 3x plus, times 2 is 6x. Inside terms, 2 times 3x is another 6x. And then finally, the last terms, 2 times 2 is 4. You can add up the 2 in the middle and get 9x squared plus 6 plus a 6, 12x plus 4. Okay. I wanted to show you that this is not the same thing as the power property. You cannot use the power property on this expression because there is a plus sign in between the 3x and the 2. The power property doesn't have a plus sign. It's just all multiplication inside there. This is why it's not okay to just go, let's maybe switch this color here to a really bright red. This is not just 3x squared plus 2 squared. You can't do that because it is not the same thing as the power property. Alright? So that's what this is saying right here. Notice that when expanding 3x plus 2 squared, you don't get to use the power property to distribute the exponent through the parentheses. Okay? The power property only works across multiplication inside the parentheses, not across addition or subtraction like you see it in here. Okay? So I want you to stop making that mistake. I mean it. Okay. So I want you to try those then on your own. Go ahead and pause the video and simplify each one of those expressions. Okay? Okay, let's see what you came up with. Voila. Okay, the first one is just an application of the power property. 4 squared raised to the 3rd power. You just multiply those two exponents, 4 to the 6th. Okay. On number 2, the base is actually -8. It's the quantity -8. So the first one has an implied power of 1. So you add your exponents, 1 plus 3, you get 4. Now here's the thing. Since this is to an even power, -8 times -8, that's going to be positive. -8 times -8 again is going to be positive. The whole thing would be the same as positive 8 raised to the 4th power because that exponent is even. So if I look at number 3, I'm again applying the power property. So each one of the things inside here gets that power of 3 being multiplied. So I have 3 to the 6th and 5 to the 3rd. How this is different is, how it's different from number 2 is that the base here is not -3, it's just 3, and there's a negative sign out in front. The difference here is that -8 was contained within a set of parentheses. It's clear that that is the number that's the base. But number 3, the notation doesn't have parentheses around -3 specifically, so the base is just 3, and I make it negative at the end, which is why even though it's an even power, I still have that negative sign on the outside of it. Okay? And then finally, it is still the power property here, 2 to the 3rd divided by 9 to the 3rd. Each one of the things in the division problem get the 3 distributed to it, and you don't get to subtract the bases because they're not the same. Okay, so use the division property to rewrite each one of these expressions using a single exponent, and then simplifying, we're going to compare our answers. So let's look at, say, this first one here. I know that this is supposed to be, I would subtract the exponents, right? So this is 3 to the 2 minus 4 is a -2. That's curious. Well, let's look at it the old way. Let's look at it like this. This is the same thing as 3 times 3. I've got 2 factors of it divided by 3 times 3 times 3 times 3, 4 of them. And I know that I get to go back and I get to cancel ones that they have in common. So chop, 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 chop. Again, whenever I go to divide these things, really I'm getting a 1. So up top I'm left with 1, and on the bottom I'm left with 3 squared. So if I look at the shortcut and I look at the long cut, I can see that these two things are supposed to be the same. So this negative exponent, 3 to the -2nd power, is the same thing as 1 over 3 squared. Okay, I want you to try the same thing on the rest of those exercises and see what you come up with, and let's see if we can generalize it at the end. So pause your video, please. Okay, so perhaps some weird things happen. Let's see here. So on the second one, x to the 3rd divided by x to the 6th, use the division property and I subtract them, I get an exponent of -3. So I go back to simplifying the expression by expanding it out and then canceling out like factors there. I get that that's the same thing as 1 over x to the 3rd. Okay, so when you have a negative exponent, what it means is basically the reciprocal, that you're supposed to take that power and put it down on the bottom of the fraction. Okay, on the third one there, 7 to the 4th divided by 7 to the 4th, well, 4 minus 4 makes it 0, the 0 power, 7 to the 0 power. And you've probably always been told, or maybe at some point been told, that anything raised to the 0 power is equal to 1, and here's the reason why. If you were to expand out the top, 4 factors of 7, same thing on the bottom, everything cancels out. And again, whenever you cancel these things out, you basically get, well, 7 divided by 7 is 1. That's why something raised to the 0 power is equal to 1. And the same thing happens with the variables on the last one. I get x to the 0 power. When I cancel these things out, it's the same thing as 1. Okay? So here are those two properties then simplified out. Negative exponents, b raised to the -n power means basically the reciprocal. I'm going to put that b down on the bottom and make the exponent positive. Okay, so that's the same thing as 1 over b to the n. What if it was negative on the denominator already? Well, to make it positive, again, reciprocal, you're going to flip it back up to the top, b to the n. Okay, and the last one is the 0 exponents. B raised to the 0 power is equal to 1. Anything raised to the 0 power is equal to 1, except, put this on here, b is not equal to 0, because 0 raised to the 0 power is undefined. Why is it undefined? Well, if I just do another one of those problems like what I did before, how about I take 0 raised to the 3rd power divided by 0 raised to the 3rd power. I'd have 0 times 0 times 0 divided by 0 times 0 times 0. Do you already see a problem? The problem is we'd have to divide by 0 there, which we're not allowed to do, so that is supposed to be undefined. Okay,